A block of mass 13 kilograms is being dragged across a horizontal rough surface by a horizontal force of 60 newtons. If the coefficient of friction between the block and the surface is 0.2, then work out the acceleration of the block. So here is our diagram. 13 kilograms, we've got the weight, the normal contact force, the 60 Newton force to the right, some kind of frictional force going left. Mu is 0.2, that's our coefficient of friction, and it's going to be accelerating in the direction that the force is pulling it. Now, because the block is slipping, that means this equation with the inequality becomes a normal equation, so we've got an equal sign there. So we can resolve vertically, resolve forces, and that gives us R minus W equals 0, which means the normal contact force is equal to the weight, which we can work out with the usual formula. And that allows us to work out the frictional force. So 0.2 times the value we just worked out for R. That gives us 25.48. Now we use F equals ma, so the resultant force resolving horizontally, the sum of forces, the vector sum of individual forces, I should say, is equal to mass times acceleration. So 60 minus the friction force, but we worked this out a moment ago, so 60 minus 25.48 is equal to 13, because the mass is 13, times the acceleration, and then we can solve that to give us a value of 2.66 meters per second squared to three significant figures.